Good day, Earth Science students. Welcome to Video Lecture Episode 9. Today we're going to continue our discussion in Section 3 of Chapter 15 dealing with the atmosphere. And remember we concluded on a question that said, how did Christopher Columbus get from Spain to the Americas? Keep in mind, Christopher Columbus had three sailing vessels that went with him. That was the Nina, the Pinta, and the Santa Maria. And they had no other source of power other than the wind in their sails based on the technology that was available to them. Every sailor discovered that the wind patterns on Earth helped them navigate the ocean. Now these wind systems are shown in the image on slide 121 there, okay, and it's also on slides 122 and 23. So let's move on to slide 122. Sometimes sailors found little or no wind to move their sailing ships near the equator. It also rained nearly every afternoon. This windless, rainy zone near the equator is called the doldrums. All right. Now, near the equator, the sun heats the air and causes it to rise, creating low pressure and little wind. The rising air then cools, causing rain again. All right. Now, let's get into something called surface winds, okay? Air descending to Earth's surface near 30 degrees north and south latitude creates steady winds that blow in tropical regions. These are called trade winds because early sailors used their dependability to establish trade routes. In other words, that was their source of income. So they had to learn how to best work within what was available in nature. Okay. Between 30 degrees and 60 degrees latitude, winds called the prevailing westerlies blow in the opposite direction from the trade winds. Prevailing westerlies are responsible for much of the movement of weather across North America. That's important for us because we live in North America. All right. Polar easterlies are found near the poles. Near the North Pole, easterlies blow from northeast to southwest. Near the South Pole, polar easterlies blow from the southeast to the northwest. Now let's move into another subtopic, and that is winds in the upper troposphere. There is a narrow belt of strong winds, and that is called the jet streams, and that blows near the top of the troposphere. The polar jet stream forms at the boundary of cold, dry polar air to the north and warmer, more moist tropical air to the south. Now, if you look at the image in slide 127, you can see what I'm talking about, but if you go to slide 128, that should help a little bit better as the image is a little bit larger and should be visually able to see. Let's move on to slide 129. The jet stream moves faster in the winter because the difference between cold air and warm air is greater. The jet stream helps move storms across the country. Pretty cool to think about. Now, on slide 130, this is pretty interesting because this applies to our lives as humans. Jet pilots take advantage of the jet streams. How do they do that? Well, when flying eastward, planes save time and fuel by following the jet stream. And when they're going west, planes fly at different altitudes to avoid the jet stream so as to not waste fuel trying to resist the stream itself. All right, now let's try to cover our last couple slides today. So we're going to start local wind systems, okay? Global wind systems determine the major weather patterns for the entire planet. Smaller wind systems affect local weather. Now, if you live near a large body of water, you're familiar with two such wind systems. They are the sea breezes and the land breezes. So let's talk about the sea breezes for today, and we'll pick up on the land breezes tomorrow. Okay, slide 132. Convection current over areas where the land meets the sea can cause wind. A sea breeze, which is illustrated in the image on slide 132, created during the day because of solar radiation warms the land more than the water. And you can see the cycle there if you look at the image with the arrows, both the red arrow and the blue arrow in the direction they're pointing. Okay, moving to slide 133. Air over the land is heated by conduction. This heated air is less dense and has lower pressure. Cooler, denser air over the water has higher pressure and flows towards the warmer, less dense air. A convection current results and wind blows from the sea towards the land. So that's a nice short summary on sea breezes. I do hope this lecture has been helpful. If you have any questions, leave them in the comments below. Have a nice day, and I look forward to seeing you in lecture. Goodbye.